Welcome to another episode of the guided tour through SAFe, where I deconstruct the SAFe big picture into a series of short videos. In this video, we're going to discuss the value stream level of SAFe. Over the last month, I've gotten a lot of requests on explaining 4-level SAFe, and this being the 4th episode, I thought it would be appropriate to dedicate it to 4-level SAFe. The term value stream refers to all the steps and the people that are involved in creating value for the customer. A simplified value stream in a software organization begins with gathering requirements from customers, analyzing them, designing a solution, followed by coding, then testing, and finally making the solution available to customers. These steps are then repeated for future product enhancements. Here's a view of the value stream in 3-level SAFe, where the entire value stream is realized by a single ART of less than 150 practitioners. One value stream equals one ART. This model is adequate for most systems development organization, and that's why it's the default view on the SAFe website. 4-level SAFe is appropriate for situations where the value streams exceeds 150 people and requires more than one ART. The value stream needs to be split into multiple ARTs. So in the 4-level model, one value stream equals many ARTs. But before we go any further, I'd like to emphasize the Agile principle that simplicity, the art of maximizing the amount of work not done, is essential, which is another way of saying deliver the highest value with the simplest solution so you can avoid the need for very large development teams. Therefore, we should strive to avoid using 4-level SAFe as it adds additional overhead to our implementation. However, there are many solutions that are large and complex by their very nature, such as commodities trading, satellite navigation system, air traffic control systems, and now self-driving automobiles. These solutions require the coordination of large numbers of practitioners from various disciplines, distributed across many locations. So the purpose of 4-level SAFe is to allow very large systems developers as much agility as possible through clear roles, artifacts, and predictable events. In this video, we will use the example of developing the entertainment system available to aircraft passengers during flight. These systems require the collaboration of cross-discipline teams of software, firmware, mechanical and electrical engineers, as well as manufacturing vendors, along with many suppliers. The total number of practitioners for this system well exceeds 800 people spread across 3 continents. Now let's walk through the artifacts at this level. Even though we agree that working software is more important than comprehensive documentation, the increased complexity and criticality of these systems calls for more rigorous documentation than most Agile teams are accustomed to. In fact, many of these systems must pass the scrutiny of regulatory audits, such as the Federal Aviation Administration, or FAA. The systems engineer specifications, user documentation, internal designs, acceptance tests, and test results are collectively known as the solution intent. Unlike backlog items which have a lifespan, these are enduring artifacts. They provide a view of the system behavior today and the plans for its future. These artifacts must also be traceable. For instance, an auditor should have clear visibility to the specifications, designs, and the test cases for the air-to-ground connectivity capability of the aircraft. As we begin the solution design, some requirements will have a fixed constraint, such as the FAA regulation that all video and audio being broadcast on the aircraft must pause during crew announcements. In these cases, developers have no choice but to comply with the precise requirement constraints. On the other hand, the FAA is flexible on the type of operating systems that power the media servers, making this a variable requirement. This allows the developers to experiment with a set of options such as Android OS, iOS, Ubuntu, and Windows 10. By following the concept of set-based design, we can craft experiments that measure the speed of movie downloads, playback quality, usability, licensing costs, and maintainability for each OS under consideration. After each iteration, we can narrow our choices based on the results, and by the end of the second PI, decide on the OS choice that holds the best promise. We want a solution to be based on the results of experiments rather than someone's arbitrary edict. Using Model-Based Systems Engineering, or MBSE, developers are free to conduct early experiments through proofs of concept, simulations, and prototypes before deciding on the most suitable technology choices. This practice is especially useful when simulating the environment where the solution will be running, known as a solution context. In our example, the solution context is a multi-million-dollar Airbus A380. And since we don't have one of these in our labs, we must simulate this environment using models and prototypes. For example, we can create a rack with 853 devices in a pressurized compartment that continuously runs an assortment of movies over a 12-hour period. This lab environment simulates an intercontinental flight of an Airbus A380 flying at 40,000 feet altitude. Using these techniques, we can increase the chances for a successful acceptance of the solution within the actual aircraft. The backlog items at the value stream level are called capabilities. Their development spans multiple arts but must fit within a PI. Examples of capabilities are the power switch, video playback, and picture-in-a-picture. The enablers are the technologies that make the capabilities possible, such as sufficient buffering of the bitstream payload to ensure smooth video playback. The roles and events at this level are analogous to those at the program level, except that they are rolled up to a higher level of abstraction. For example, the value stream engineers coordinate the work of all the RTEs. The solution manager ensures that all the product managers have defined the content for their respective arts, and the solution architect ensures that there is a seamless solution architecture binding the user experience and the interfaces between arts. The roll-up of art system demos results in a solution demo at the value stream level. The PI planning and inspect and adapt at the value stream level is also a roll-up of the PI planning and inspect and adapt of each art. In this fashion, we're able to aggregate and scale the agility of individual arts to a much larger value stream. Now that we've covered all the levels of SAFe, we can move on to discuss the backlogs at each level. If you would like to get a deeper understanding of 4-level SAFe and how to implement SAFe in your organization, be sure to check out my upcoming class in Irvine, California on November 1 through 4. Just look for the link in the show notes. Also, please leave comments and questions so I know what areas to focus on in future episodes. I'm Armin Merabian, and thanks for watching this video.